All right, so now we're going to look at solving a log equation. So example 4, we have log base 4 of 2x plus 8, and that equals log base 4 of 6x minus 12. So this is kind of a special situation where if we have two logs that are equal to one another and they have the same base, you can see that they both have base 4 there. Well, then what does that mean about 2x plus 8 and 6x minus 12? Right? If they're sitting there equal and we have the same exact base there as well, well, it makes sense that the insides would have to be the same thing as well. There's no other way around it. So we can just simply we can get rid of the logarithms and just say that just means that 2x plus 8 has to equal 6x minus 12. And that is a simple way to break this problem down and solve now. So now we just get x by itself, where we collect the x's and get the numbers on the other side. Right, so I'm going to subtract 2x from both sides and get 8 equals 4x minus 12. And then I want to add 12 to both sides. And I'm going to have 4x is going to equal 20. And then divide by 4 to get x equals 5. So that's one kind of possible situation you may have. If you have two logs that are equal to one another, that means that the arguments inside of that log have to be the same as well, and we can just set them equal to one another. Let's try one that's not like that. So here's a kind of a basic log equation where we have a log base 7 of 3x minus 2 equals 3. Right? Well, how do we solve for x here? Right? So if I ask some people and they think about, all right, well, how do I get x by itself? Well, some people might actually go back to their normal linear equation solving, and they might say, well, just divide a log base 7 on both sides. I get rid of that logarithm, and then it's gone, right? Definitely, so you definitely can't do that. We have to think about what's the inverse, or how do I get rid of a logarithm? The easiest way here is just to go back to what we've been doing before, which is just rewriting the problem. And that is using the definition of a logarithm to rewrite this. I'm just going to say rewrite in exponential form. AKA, if I was in class right now, I would say, oh, go ahead and use shark fin or shark fin it. Right? I'm going to shark fin this. I'm going to rewrite this problem and say this base 7 raised to this number, 7 raised to the 3 equals 3x minus 2. So I'm going to go ahead and do that. 7 cubed equals 3x minus 2. Now that I rewrote that, you can see that this problem down here does not have a log in it. So just by rewriting that, the log goes away. And I should be able to solve this problem from here. So what is 7 cubed? 7 cubed is 343, and that equals 3x minus 2. Then I'm going to add 2 to both sides and get 345 equals 3x. And then I can divide by 3 to get x equals 115. And there's my answer. All right, so let's try another one of those. Here's a log equation, and the only thing that's different about this is first we have the 6 out in front, which is not part of the log, and we can simply, if we have some stuff around this log expression that we have right here, we're just going to get rid of everything else. We're going to isolate or get by itself that log expression. So I'm going to divide by 6 on both sides first. Then I'm going to get log of 3x plus 16 equals 2. Now the other different thing about this problem is that the base is not written there. Well, we learned this in that last section, 7.4. If the base is not written there, just like if I have a square root and the index is not written there, what do we assume this number to be right here? We assume it to be a 2 because it's really common to have a square root and it's used so much. What base do we assume right here? Right, that is 10. The common log base is a 10. So you can either write it in there or just know that it's 10. But now we do the same thing as that last problem. How can we rewrite this problem so it's easier to solve? Let's rewrite it in exponential form. So our base is 10 and we're going to shark fin it. We're going to say 10 to the 2 equals 3x plus 16. So 10 to the 2 equals 3x plus 16. We can go ahead and say this is 100 equals 3x plus 16. And then we can do our 2 steps here. So subtract 16, and we'll get 84 equals 3x. We can then divide by 3, and we can get x equals 28 for an answer. Okay? So when you have a log equation like this, you want to get the log expression by itself, if necessary, and then shark fin it. Shark fin is your answer there. Rewrite that equation in exponential form, and then that will allow you to solve for x. All right, so here's a couple practice problems. If you feel like you got the idea here of log equations, you could be done here. If you want to try those 2 practice problems just to see how, just to see if you got it, go ahead and do it. You can pause it. I'm just going to walk through these a little bit quicker now. So part A, this is a log equation. We already have the log expression by itself, so I'm going to shark fin it and say 3 to the 6 is 4x. So 3 to the 6 is 4x. And we have 3 to the 6 is 729. 729 equals 4x. And if I divide by 4, I get 182.25 is my answer for A. D, I have a 2 out in front here, so I want to get rid of that first. I'm going to divide everything by 2. So I'm going to get the log of, or the log with a base of 1.5, 3x minus 4 equals 4. Now that I have that, I'm going to shark fin it. So 1.5 to the 4th is equal to 3x minus 4. So 1.5 to the 4th is equal to 3x minus 4. So I'm going to go ahead and type in my calculator 1.5 to the 4th, which is going to be 5.0625 equals 3x minus 4. Then I'm going to add 4. So that's going to give me 9.0625 equals 3x. And then lastly, divide that by 3. 9.0625 divided by 3 is going to be x is, and here I'm going to round, so I'm going to approximate, and I'm going to say it's about 3.0208. It looks like it goes 3333 repeating. So I'm going to approximate this one and just say that's about 3.0208. So there's log equations. Again, the key to that is, first of all, the first example that we did was what if you have a case of 2 logs equaling one another? Well, then you can set the insides equal to one another and solve. But if you have just simply one of these log equations that it's not like that, you can just rewrite or use shark fin to solve your problem. Right? And that's it.